Chapter 20. Map Reading. Equipment. This chapter assumes that the reader is using a Silva or a Silva-type compass. From a tracker's point of view, I have found that the best types of map to use for tracking are the different series of the Ordnance Survey. The smallest scale that is of any real use is 1 in 50,000. Ordnance Survey maps with larger scales contain proportionally more detail. Depending on the area and speed with which you are moving, you can decide which map is the most appropriate, taking into account the difficulties of handling many large-scale maps if you are moving rapidly over an area. Other countries produce similar quality maps if you are working abroad. I have been asked why map reading and compass bearings are important when one can use modern technology, sat-nav, etc. My answer is another question. What happens when your technology fails? Your skills will be essential to survival. The uses of map reading to a tracker team. I deliberately left out map reading as a quality of a tracker in Chapter 5 because many of the world's best tracking groups have probably never seen a map, let alone know how to read one. But, having said that, it is not a necessity. I still maintain that it is a great adjunct to a tracker's skill set for the following reasons. Selection of the quarry's likely route, location of your own position, prediction of the quarry's actions, collating the information and intelligence from other trackers or other pursuits, planning preemptive operations based on tracking information and intelligence. Map reading subjects and skills. The following subjects and skills have been selected as being of particular relevance to a tracker. Map reading and navigation are a huge subject. Therefore, the following critical selection provides the student of tracking with subjects he needs to understand and skills he must master to track over unfamiliar terrain. Conventional symbols and other information contained in the map's margins, features of the compass, setting the map, measuring distances, using grid references, understanding the different north points, converting bearings from grid to magnetic and vice versa, taking bearings from the map and assessing your direction of travel, plotting positions by resection, estimating distance covered, speed. Conventional symbols and other margin information. The most important skill in map reading is to be able to read the map. A good map reader can look at the map and immediately start to form a mental picture of the ground. This takes time and practice, but is a skill that can be learned by all with time and patience. The secret to this technique is the interpretation of the signs and symbols used on the map, especially the contour lines that help to visualize the relief of the ground. Maps are used everywhere in daily life. There are many different types of map. You will have used the road map from a garage, or a map of the subway, or a street plan of your hometown. Each map type is designed for a particular purpose, but they are two-dimensional representations of the real world. They convey information to the reader via the symbols they use. The key to these symbols is always on the map's margins, along with other essential information such as the scale and the date of publication. See Figure 56 on page 244 for examples of legends that show the symbols and their meaning. Features of the compass. The Silva compass itself, Figure 54, is usually mounted at one end of a transparent plastic plate measuring approximately 12 centimeters by 6 centimeters, which will have a direction of travel arrow, usually luminous. Incorporated with this base plate, you may find a magnifying lens. The short side away from the compass is beveled. Along the sides of the base plate are various measures, and the short end away from the compass is usually designed as one of a set of roamers. See using grid references below. The compass housing rotates, and on this rotating bezel are the fixed calibrated compass points. The orienteering or Silva-type compass is calibrated either in degrees or, for the military, in mils. This system need not concern the civilian tracker. The bottom of the compass plate is marked with a series of lines running parallel to the north-south calibration and marked with a north arrow. The compass needle, the north half of which is red with a luminous tip, swings freely within this housing. Setting the map. By setting or orientating the map, we mean holding it in such a way that the details on the map correspond to the features on the ground. There are two ways to set a map: the inspection method and the compass method. The inspection method. This is the easiest way, but you must have some idea of where you are on the ground. If you're standing on a straight section of road with a road junction either side of you and signposts, line up the road on your map with the road you're standing on, making sure the map is pointed in the right direction with reference to the locations indicated on the signposts. If you're not on a road, another linear feature will serve the same purpose, or you may have to find prominent features on the ground that you can identify on your map, such as a church, bridge, crossroads, river, or stream junction. By identifying features on the ground and on your map, you will be able to move your map so that it corresponds to the lie of the land. This is orientating or setting your map by features recognized both on the ground and on the map. The compass method. This is done by holding the map so that the north of the grid lines of the map are pointing to the north. To effect this, one has to take into account the magnetic variation. Using a civil-type compass, set the magnetic variation on the direction of travel line. See taking bearings below and the different north points. Then place the compass on the map so that the direction of travel arrow coincides with the north direction of the grid lines. Then rotate the map with the compass laid on top of it until the compass needle coincides with the north pointer of the parallel lines. See Figure 55. The map is then set. Measuring distances. It is important that you should be able to estimate and measure distances from your map. If you're moving across country, you don't want to miss your objective because you have miscalculated the distance and time it takes to get there. Scale is the relationship between the size of your map and the area of ground it depicts. Scale is determined by the number of times the map is smaller than the area of ground it depicts. The scale shows you the direct relationship in terms of distance between map and ground. By looking at the scale on the map, you can tell how many centimeters on the ground are represented by 1 centimeter on the map. The Standard Ordnance Survey map has a scale of 1 to 50,000. If you walk 50,000 centimeters, 500 meters, you will have covered 1 centimeter on a 1 in 50,000 scale map. Check the scale of your map and ensure that you know what size the grid squares are, using grid references below. On most maps, you will find that the grid squares are 1 kilometer square, each side being 1,000 meters in length. Therefore, the distance from corner to corner is, for approximate calculations, 1.5 kilometers. Most maps will have a scale bar marked along one edge of the map. The easiest method of measuring a straight line distance is to take a strip of paper and mark the 2 points between which you want the distance on the paper, and then read off the distance on the scale bar. To measure the distance along a road or a river that winds about, simply consider the road to be a number of straight line sections. Lay a piece of paper along the first leg and pencil in the start and finish of this leg. Then, starting at the finish point of the first leg, pencil in the start for the second leg, and so on, until the total distance is marked out along the edge of a piece of paper. Measure this on the scale bar to find the distance of the ground. Using grid references. A grid is a series of equally spaced, parallel, numbered lines superimposed on the map detail, both vertically and horizontally, to produce a pattern of squares. By the use of this pattern of squares, it is possible to give a unique numerical description of a position. This is known as the grid reference. To be absolutely accurate is an alphanumeric description because a full grid reference is prefixed by 2 letters that the Ordnance Survey has allocated to it to distinguish the number from where it will repeat itself elsewhere in the country. To be able to give and apply grid references, it is necessary to understand eastings and northings. The eastings are the vertical lines of the grid system, running north to south on maps and numbered from left to right, east. Northings are the horizontal lines of the grid system, running west to east and numbered from the bottom to the top, north. A 4-figure grid refers to one complete grid square. It is defined by the lines that cross at the bottom left-hand corner of the grid square, the southwest corner. In Figure 56, the 4-figure grid of the square with the X is grid reference 2257. A 4-figure grid reference is made up from the 2-digit eastings followed by the 2-digit northings. Easting 22 and northing 57 together give the grid reference 2257, which defines the grid square with the cross in it. Use the system when you want to refer to an area contained within a grid square on your map, or when there is only one object or feature of the same type within the grid square. For example, the church with a tower in grid 2257 and the bridge in grid square 2457. It is essential to remember that when reading a grid reference, we always put the eastings first, followed by the northings. There are many ways to remember this, such as E comes before N, or that you go across the map for the eastings and up the map for northings. Therefore, you go through the door before you go up the stairs. Look again at grid square 2257 with the X in it. You will see that there are two churches, one with a tower and one with a spire. To identify either of these churches, you would have to give a further description, or alternately, you can identify your church by giving a 6-figure grid reference. This refers to one point on the map, and it is accurate to within 100 meters. The grid reference of the church with the tower in grid square 2257 would be 222578. And the bridge in grid square 2457 would be 249573. The two extra numbers in the 6-figure grid reference are the third and sixth figures. These extra numbers represent tenths of the grid square. The grid square is divided into tenths, both across and up the square. You then judge how many tenths across and how many tenths up the feature is. In grid square 2257, look at the location of the church with the tower in the northwest corner. The easting is 22 plus 2 tenths, giving 222. The northing is 57 plus 8 tenths, making 578. This gives a full 6-figure grid reference of 222578. A device called a roamer, which has a right angle marked in tenths for both the vertical and horizontal axis, enables you to give a 6-figure grid reference at a glance. See Figure 5.7. Simply place the corner of the roamer on the feature and read off the third and sixth figure for eastings and northings. Silva-type compasses have a built-in roamer that cuts out the estimation in giving or plotting a 6-figure grid reference. Two features of roamers need noting. The first is that they are calibrated for specific scales, and therefore you have to use the correct one. Secondly, if the point falls between two markings, always take the lower number, not the nearest number. This is because the grid reference is pointed out with a 4-figure grid reference, refers to the southwest corner of the particular square you're describing. Remember, with a 6-figure grid reference, first give all 3 figures across the eastings before you give the northings. The different north points. There are 3 norths indicated on Ordnance Survey maps. They are true north, magnetic north, grid north. True north is the direction of the North Pole and is shown by the lines of longitude on a map or chart. Magnetic north is the direction in which a freely suspended compass needle points, and because of the physical characteristics of the Earth, it varies annually and by different amounts in different regions. All this information will be written in the margins of the large-scale maps that you use as a tracker. Grid north is the direction of the grid lines on the map. This is different from true north because the grid lines on a flat map cannot geometrically fit identically to the lines of latitude and longitude on the curved surface of the Earth. Converting bearings. The bearing you take off a map is a grid bearing, whereas the one shown by your compass is a magnetic bearing. Therefore, you need a system to be able to convert from one to the other. The method is to check the information on the map about the magnetic variation, whether it is east or west of grid north, its annual rate of change for the area, and the date of publication of the map. From these facts, you can work out the magnetic variation today. A way to remember which way the conversion goes from magnetic to grid bearings is: from mag to grid, get rid. From grid to mag, add. Note, this rhyme only applies if magnetic north is to the east of grid north, otherwise the rule is reversed. But for the most part, in Britain the rhyme applies. Taking bearings from the map and assessing your direction of travel. Using an orienteering type compass, line up the edge of the compass with the plate on the objects between which you want the bearing. Ensure that the direction of travel arrow is pointing in the appropriate direction, that is, normally from where you are to where you want to go, Figure 58. Rotate the compass housing until the parallel lines in the base of the housing are parallel with and in the same direction as the north-south grids lines of the map. This is the grid bearing between the 2 points. Before you can use the compass to assess your direction of travel, you have to adjust this for the magnetic variation. See above. When you have rotated the compass housing so that the reading against the direction of travel arrow takes into account the magnetic variation, usually by adding several degrees in Britain, you now have the magnetic bearing set on your compass. Your intended direction of travel is found by holding the compass horizontally, so that the compass needle is free to swing, and by moving it around until the north of the compass needle is superimposed over the north pointer of the parallel lines in the base of the compass housing. Plotting position by resection. If you're unsure of your position, you can plot it accurately on the map by using resection. Basically, all you have to do is locate two objects or features on the ground that you can identify on the map. Take bearings visually to them from where you are, convert these magnetic bearings to grid bearings, plot the two bearings on the map. Where the lines cross is your position. To find a bearing from you to a feature, simply point the direction of travel arrow at the object and then, holding the compass horizontally, rotate the compass housing until the north pointer on the housing base is under the compass needle. Remember, this is a magnetic bearing and needs to be converted before putting on the map. Estimating distance covered, speed. As well as being able to use the above-mentioned skills, you should take time to consider how far you're able to move in different types of country and weather conditions. You can estimate this by knowing that your average pace is for the various conditions. For example, walking on a flat road, you may cover 4 miles per hour. Therefore, if you've been walking for 45 minutes, you will have covered 3 miles. Another way is to count your pacing. If you know how many paces you take to cover 100 meters, then it is quite easy to work out the distance you have covered. The best way to do this is to measure your pace over a known 100-meter distance, counting every time your right foot touches the ground. Do this walking, then again running, and note the difference. You will find a difference going up or downhill and in different terrain and weather conditions. As a basic guide, I average about 64 paces per 100 meters walking and 40 to 45 when running. In the time it takes to walk 200 meters on the flat, you could climb a 25-meter slope, cover 150 meters through primary forest, or travel 50 meters through thick undergrowth. With experience, you will be able to make a good informed estimate of the distance you have traveled. As I mentioned earlier, map reading can never be considered a prerequisite for tracking, but if you intend to track anywhere other than your own area, it is an important skill. Not only does it make the relaying of information easier, but it adds interest and can be essential for safety in remoter areas. Summary: equipment, Silva or Silva-type compass, ordinary survey map, 1 in 50,000, or map of similar quality. Uses of map reading to a tracker team: selection of the quarry's likely route, location of your own position, prediction of quarry's actions, collating information and intelligence from other trackers or other pursuits, planning preemptive operations based on tracking information and intelligence, map reading subjects and skills, conventional symbols and other information in margins, features of the compass, setting the map, by inspection method, by compass method, measuring distances, using grid references, understanding the different north points, true magnetic, magnetic north, grid north. Take bearings from the map and assessing your direction of travel. Plotting position by resection, estimating distance covered and speed of travel.